In this lesson, we're going to look at the first things in the universe.
We know that just after the Big Bang, the universe was incredibly uniform. It was this hot, glowing fog we've talked about so many times. But if you look at the universe today, you can see it's very lumpy. The density up there is 20 orders of magnitude less than the density down there. How did it go from being so uniform to so lumpy?
And that's not the only interesting thing. The universe, as we recall, was born with 3 parts hydrogen to 1 part helium and basically nothing else. And yet when we look around Earth today, we see rocks. Rocks are made out of things like aluminium and oxygen and silicon and magnesium. And then there are other interesting things like gold. So let's review Big Bang nucleosynthesis. This is when the entire universe acted as a giant nuclear reactor.
So what we have here is the nuclear calculation. Remember, this is a calculation we know very well because it's useful for killing people. What we plot here is the amount of different elements on a logarithmic scale. So each mark here is a drastic drop in the amount of these things, and time after the Big Bang. So not much by, that's log time, so that's 10 seconds after the Big Bang, then 100, then 1,000 seconds, and you see the amount of hydrogen goes down very slightly, the amount of helium comes up, and you also produce a bit of deuterium, helium-3, a few other odds and ends, but that's about it.
So we end up with 1 part hydrogen, 3 parts hydrogen, 1 part helium, and 1 part in 100,000 of everything else. So almost nothing but hydrogen and helium in the universe. And yet, when we go and we look what's in the sun, look what we see. We see that, sure, the sun is largely made out of hydrogen, 71%, and it has about 25% helium. But then there's all this other stuff. I mean, 12% of this, or 0.12% of the sun is iron. And iron wasn't made in the Big Bang. So we have to figure out how that stuff got here.
If you look at the Earth as opposed to the Sun, we've got most of the hydrogen and the helium are gone, but the pattern of the other elements is actually very much the same. And this whole pattern of the elements, you see it's a very zigzaggy sort of pattern with rather strange bumps and so on, determines a large fraction of how the economy of the world works. For example, the fact that iron is higher up than gallium tells you that iron's probably going to be cheaper than gallium. Likewise, gold is much lower down than iron. If it was the other way round, then you'd be wearing iron jewellery and building your cars out of gold. So this pattern, some elements are common, some are not, but they've all had to come from somewhere. None of them are produced by the Big Bang apart from the hydrogen and helium, which we don't have much of on Earth anyway.
So let's think about where we might find these elements.
To understand where elements come from, we will have to understand nuclear physics, nuclear fusion processes which allow different elements to fuse together. And these are studied at nuclear physics departments and research institutes around the world, including at the Heavy Ion Accelerator here at the Australian National University. Ions are accelerated from a huge tank in the tower, speed downwards at ever greater speeds, and then are deflected sideways into the various laboratories.
Hi, I'm Caitlin. I'm a PhD student here at Nuclear Physics at the ANU, and this is the target area where we do all the experiments. So what happens is the particle beam comes from the tower, behind us over there, through this magnet and down this beam line into our experimental apparatus. So this is one of our detector arrays. So what happens is the beam comes through from here and hits a target, which is just an elemental target in the middle of this array. And here are 4 silicon detectors that we use to pick up particles that come out of reactions.
It is at places like this that experimenters work out which reactions can happen, how fast they can happen, what conditions they will happen under, what the end products will be, all the things we need as inputs to our calculation to work out where the elements actually come from.